Okay, in this section we're going to talk about permutations and combinations. But before we can get to those critters, we need to talk about something called factorials or factorial notation. Basically, if you see something like this, it doesn't mean that the 5 got excited. You read that in mathematical terms, you read that as 5 factorial. And what it means is you just simply multiply from 5 all the way down to 1. So 5 factorial would actually be calculated this way. 5 times 4 times 3 times 2 times 1. And always stop at 1 because it wouldn't make sense to go to 0 because everything would be 0 if you did that. So 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120. Now, the definition of n factorial, some students have trouble understanding this notation, the definition. Well, n factorial is actually, well, let's start here and I'll show you. So 4 factorial we know is 4 times 3 times 2 times 1. Okay, well here n is 4. So notice what I'm doing. I'm taking the number 4, which is n, then I'm multiplying it by the number 3, that would be n minus 1. Then I'm multiplying it by the number 2, which would be n minus 2, and then you always stop at 1. So that's what that notation is saying. It's just saying to get n factorial, multiply by n, then n minus 1, n minus 2, until you get down to 1. And that's how you find factorials. Now 3 factorial would be 3 times 2 times 1, which is 6. 2 factorial, 2 times 1, which is 2. 1 factorial is 1. 0 factorial, you're just going to have to remember that 0 factorial is always 1. So just put that in your memory banks, and if it bothers you, then don't let it bother you. Okay? 0 factorial is understood to be 1. Okay, now calculating factorials, let's say you wanted to calculate 15 factorial. Well, you could just enter this into your calculator. 15 times 14 times 13 times 12 times 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But there's other ways to enter it using a calculator, and I'll show you how to do that in a minute. At least I'll show you where you can. But let me show you a little trick that you can use. Like if you were doing a quotient of 10 factorial over 9 factorial, well, it turns out that 10 factorial, we already know, is 10 times 9 times 8 times 7 all the way down to 1. But if you look at this part, 9 times 8 times 7 times 6 times 5 all the way down to 1, that's 9 factorial. So what I could do for this, since I have a 9 factorial in the denominator, I could write 10 factorial as 10 times 9 factorial here, and then I could actually cancel because I would know that 9 factorial over 9 factorial is just 1. And so I would just get the answer 10. See, so that's a little trick. If you don't have a calculator handy, you can do that. Here's another example. You actually can take it down further. Like here I have 7 factorial. Well, 10 factorial can be written as 10 times 9 times 8 times 7 factorial. And then I can cancel the 7 factorials and then just figure out what 10 times 9 times 8 is, and that gives me 720. A couple of warnings here. 3 factorial times 4 factorial doesn't equal 12 factorial, and 4 factorial divided by 2 factorial does not equal 2 factorial. Because factorial notation means you have to calculate the factorial first. So 3 factorial would be 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1, or just 6 times 24. So that would give you 144. And obviously if you did 12 factorial, that's going to be much greater than 144. And then similarly over here, you do the 4 factorial on top, then you do the 2 factorial on bottom, get 24 over 2, and you get 12. Now, most scientific calculators will have a key for n factorial. So what I would suggest you do is you go to YouTube and type in a query about how to solve factorials on my calculator. So if it's a TI calculator, say how to solve factorials on my TI-84 calculator. And I'll guarantee you, you'll find a video, you'll find a bunch of videos that they show you how to do this. And basically, all you have to do is figure out how to get 5 factorial into your calculator and then just hit enter and it'll give you the right answer. And that way you don't have to multiply these factorials out. Now, I don't have time to teach you calculator techniques on here, but you can easily do that. You can easily find that information on YouTube. Okay, so now let's do some simple factorial problems. Now, a factorial is actually a multiplication principle where you use all of the objects. In the previous section, we asked how many 3-letter code words could you create from the first 9 letters of the alphabet without repetition. What if I changed it to how many 9-letter words you could create? Hang on just a second. I think I've got something misstated here. Well, actually, I asked you for with repetition and without repetition. So with repetition, remember, it was 9 times 9 times 9. But without repetition, it was just 9 times 8 times 7. Okay, so let's change it to how many 9-letter code words, how many 9-letter code words you could create without repetition. So there's 9 choices for the first letter, 8 choices for the second letter, 7 choices for the third letter, and so on. So basically, if you wanted to know how many 9-letter code words you could make out of the first 9 letters of the alphabet, it would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But we know that that calculation is simply 9 factorial. So all you have to do is figure out how to punch 9 factorial in your calculator. Okay, here's another example. Suppose 8 amino acids must line up perfectly in a certain order for a bodily function to work properly. How many ways could these amino acids line up? Well, since they're different amino acids, you can't have repetition. So there's 8 choices for the first amino acid. Then that leaves 7 choices for the next amino acid, 6 choices for the next, and so forth. And then once you get down to the last one, there's only 1 amino acid left to line up. So that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 8 factorial. Well, let me go ahead and introduce permutations here. I'm going to do it with an example. Suppose we take the word math that has 4 letters in it and want to know how many 2-letter code words without repetition, okay, no repetition, we could create. We could do it the hard way by listing each possibility. This is called the exhaustion method. Okay, so MA would be a 2-letter code word, but so would AM. MT and TM would be 2-letter code word. MH and HM would be a 2-letter code words. AT and TA would be 2-letter code words. AH and HA would be 2-letter code words. And then finally TH and HT would be 2-letter code words. Well, I counted 12. Each of these code words are what we call 2-letter permutation of the 4 letters. So I'm not getting 4-letter permutations. I'm only getting 2-letter permutations. So what a permutation is it's simply an arrangement. So each of those 2 up there, MA, AM, MT, TM, and so on, each one of those is a 2-letter arrangement. Okay? Each is a 2-letter arrangement. And I could have said how many 3-letter code words or even how many 4-letter code words. So this leads to a definition of permutation. Okay. A permutation of a set of distinct objects is basically an arrangement of the objects in a specific order, and then you can't have repetition. So consider the example above. MA is one arrangement of the two objects, so that would be a permutation. And now repetition was not allowed, and MA is a specific order because AM would be a different code word. So actually each of the 12 code words is a different permutation. Let's look at another one. Let's say that we have these 4 numbers to choose from, and I want to ask you to list all of the 3 object permutations of this set. Well, you could list them all by the exhaustion method: 736, 763, and so forth, 367, 376, 637, 673, and things of that nature. So basically you could come up with all of these, but what you're going to find out is you're going to find out that there's 24 ways you can arrange 3 letters out of these 4. In other words, there's 24 3-letter arrangements of the 3-number arrangements of the 4 numbers. Now, but you already knew this from the multiplication principle, because if I said how many 3-number arrangements are there, there would be 4 ways for the first number, and repetition is not allowed, so that leaves 3 numbers left for the second number, and then that would only leave 2 numbers left for the third number. So 4 times 3 times 2 is 24. Now, if repetition was allowed, I would have ran off the page because I would have had 4 ways to choose each number. So each number could be 7, 3, or 6, or 4. So there's 4 ways for the first number, 4 ways for the second number, 4 ways for the third number. So, but those aren't considered permutations because in that case repetition would be allowed. All right, let's look at this example. Suppose a police officer must line up 6 people for a witness to identify the perpetrator. How many ways can the officer line them up? Well, ask yourself some questions. Can the people be repeated? Like, can you take a person and put him at the number 5 spot and the number 3 spot? Well, no, you can't. You can't do that. So repetition is not allowed. Is the order relevant? Yeah, of course it is, because if you always put the criminal in, say, the 5th spot, then, word might get out, and people would know that the criminal is always in the 5th spot. So obviously, it's got to be some sort of random alignment, so order matters. So actually, this is actually a permutation problem. This is a permutation problem, and we would have, it's a permutation question, and we can solve it with multiplication principle. So using the multiplication principle, there's 5 ways, there's 5 people you can put in the first slot. Okay, and hang on just a minute, this should be a 5, not a 6. Typo. Okay, so there's 5 choices for the first spot, 4 choices for the second spot, 3 choices for the third spot, 2 choices for the fourth spot, and 1 choice for the last spot. Okay? And so that would give us 120 possible lineups. So the key word for that example was obviously you could not repeat. You couldn't put the same person in the same spot in 2 different spots. And it was a specific order, so the order mattered. Okay? So basically a permutation is simply a multiplication problem without repetition where order is important. For example, if you had 12 players on a baseball team and wanted to know how many batting orders you could submit, this would require a permutation formula. For one, you would not list the same player batting first and fifth, so that means there's no repetition. Also, if you lead off with John Doe batting first, but next time you use the same 9 batters, putting John Doe as the 9th batter, that would be a totally different batting order. So that, in other words, that next batting order would be a totally different permutation. Even though you use the same 9 batters, it would be a totally different permutation. So really what we're going to learn here is that when the order matters, it's a permutation. Now if order doesn't matter, then you're only worried about the number of subsets that you can get, and then that's called a combination. And I'll finish this on the next video.